Okay, so we're going to talk about simplifying radicals, which we've spoken about in the past. There's going to be a little bit of a review of how to do it with numbers that are perfect squares or cubes and are not perfect squares. Um, so let's just go over simple stuff like how do we find the square root of 25? There are Khan Academies on finding square roots and cube roots. If you haven't done them already, this is just quick practice. But also, so let me just show you. So if you have the square root of 25, the square root of 25 is going to be what squared equals 25, and that's going to be 5 because 5 squared equals 5 times 5, which is 25. All right, next. What cubed, meaning what multiplied by itself 3 times gives me 27. You can use a calculator for this, or you can try to figure it out. 2 times 2 times 2 is 8. 3 times 3 times 3 is 3 times 3 is 9, and 9 times 3 is 27. So this is going to be 3 because 3 cubed equals 3 times 3 times 3, which is 27. So that's what it's asking when it says, what is the cube root of something? What number cubed gives me 27? Also in your Khan Academy, just a little side note, you'll have things like so the square root of 144 is 12, but the square root of 1.44 is 1.2. Notice the similarities here. Is that 1.44 and 1.2, 144 and 12. You'll see numbers like this, right? So you'll see the square root of like 169, 1.69. Well, the square root of 169 is 13, so it's 1.3. So seeing those similarities. What about if we have variables? So this is asking, what is the square root of x squared? So the square root of x squared, so you ask yourself, what squared equals x squared? Well, this one's pretty easy. X squared equals x squared, right? So the answer, I should have done this in an opposite color, right? So it's going to be something squared equals x squared. The answer is x. So the square root of x squared is x, which we know from solving square root equations. We know that the square root is the opposite of the square. So therefore, the square root of x squared is just x by itself. But then what happens when we have something like this? The square root of x to the fourth is what squared equals x to the fourth? Well, we know from our exponent properties that when we take the power of a power, we multiply. So x to the what squared equals 4? Well, what times 2 equals 4? 2. So it's going to be x squared equals x to the fourth. So the answer is x squared. So now here's the key. What is the number here technically? So we see here how this is a 3. Well, what's the number here? Technically, the number here is a 2, right? We don't write it here the same way that if I have x to the first power, we don't write that first power. It's an implied number in math. So that 2 is implied. So the easiest way to do this is the same way how when we take the power of a power, this is a 1 here, we do 1 times 2, which is 2, 2 times 2, which is 4. With this, we're kind of going backwards, right? So I'm going to do 2 divided by 2 equals 2. So we're going backwards. We're trying to find what times 2 equals 4. So 2 divided by 4 is equal to 2. So that makes this problem a heck of a lot easier, right? Because if that's a 2 and 10 divided by 2 is going to be 5. So the answer is x to the fifth. And we know that that's true because x to the fifth squared is equal to x to the 10th. What about this? So we have x to the 9th, the cube root of x to the 9th. Same rule applies, right? What cubed equals x to the 9th? Well, if we divide 9 by 3, it's going to be x cubed. Notice in all of these, the base has not changed. X is still X. So that does not change. Okay, so what about this problem? This problem we are going to treat as just two separate issues. The square root of x squared and the square root of y to the fourth. You don't always have to separate them, but it's important to look at them as two different things. Excuse me. So the square root of x squared, we know, is x. They just cancel each other out, x to the first. And the square root of y to the fourth, remember, 4 divided by 2 is going to be y squared. So my answer is xy squared. Now, I put up here, and I forgot to mention it, but assume that all values of the variables are positive. This is important because if we do not assume that they are positive, then other things happen, which you'll learn in Algebra 2, but for Algebra 1, it's important to note that they are all positive. Okay, now, what if there are non-perfect squares inside of a square root? Now, 8, the square root of 8, is 8 a perfect square? No, it's not, because nothing squared will give me, no integer squared will give me 8. If we put it into a calculator, you will get 2 point something. Okay? So it's really important to know that it is not a perfect square. So what do we do? And I have videos already on this, and I have linked them on my website if you want the in-depth lesson. But just a quick review. You can find the biggest perfect square, which is 4, and find the square root of 4 times 2, which is the square root of 4 times the square root of 2, and square root of 4 is 2 root 2. Or you can break it down, right? 4 times 2, 2 times 2. And so this is what we got for the first answer. For this one, it's going to be the square root of 2 times 2 times 2. The pairs come out, and so therefore the pairs come out as 1, so it's a 2, and the 1, 2 on the inside stays. Still, you get the same answer, two different methods. So I know this is 2 root 2. I almost always use this method. I think it's more mathematically quick, but this just breaks it down more. This method breaks it down more. This method is a little bit just more quick, and either way, either method works. I just always tend to go towards the perfect square method. So I'll do both methods for the 27. Square root of 27 is not a perfect square. So we can find the biggest perfect square that goes into 27. So we could think about it, and it's going to be 9. So 9 times 3, square root of 9 is 3, and then 3 stays inside. So it's 3 root 3. No, it will not always be the same two numbers. Or you can break it down, and you'll get 3 times 3 times 3. Let's do one more of these. Let's do the square root of 24. So if I break down 24, I'll use the other method. So if I break down 24, I can do 12 and 2, 6 and 2, and 3 and 2. So this breaks down into a 3, a 2, a 2, a 2. So there's only a pair of 2s. So the pair of 2s can come out, which is just going to come out as 1, 2. And what stays inside is the 3 times the 2. So this is the 2 that came out. The 3 and the 2 stay inside. And so we have 2 root 6. The other way we could have done it is, what is the biggest perfect square that goes into 24? It is 4 times 6. And the square root of 4 is 2 root 6. Either way, you get the same answer. I just happen to think the other way is quicker. So 2 root 6. Now, this is how we do numbers that are not perfect squares. Again, if you need a more extensive review on it, you can use the other videos that I have created that are linked on my website. But what if we have variables like this? So we have the square root of x cubed. Now, this nothing squared is going to give me x cubed unless, and if we divide it, we will get 3 over 2, right? 3 over 2 is 1.5. So what we're going to do is we are going to do this. We're going to break this up, and basically we are going to find the biggest perfect square that goes into x cubed, which is x squared. Now, let's make one thing very clear. X squared is a perfect square because x times x is x squared. But the reason we are breaking this down into a 2 and a 1, now x squared times x is x cubed. This and this are the exact same thing. I've just broken it down because, again, this number here, it's called the index or the root, is a 2. So when I break this down, and if I split this up into x squared and x to the first, and just x or x to the first, it doesn't matter, this right here is going to become what? The square root of x squared is what? X to the first. And then this, I cannot simplify any further, and I keep it as x. So I have x root x. Let's try another one. Okay, so if I have x to the fifth. Wait, hold on. Before we do that, one thing I want to show you is the division issue. The division aspect here also works. Notice I have a 3 here, and I have a what here? We've said it a million times. 2, right? So if I do that dividing portion, right, where I have 3 divided by 2, x to the 3 divided by 2. What is 3 divided by 2? What with a remainder of what? How many times does 2 go into 3? 1 time with a remainder of what? 1, right? It is 1 with a remainder of 1. This right here is your 1 here, and this right here is your 1 here. And you will see that happen for every single case. Let's look at this problem. So if I break this down, I want to make this into 5 is not an even number. It is not evenly divisible by 2. So I'm going to change it to x to the 4th times x. I'm always going to go 1 down when we're dealing with square roots. X to the 4th times x, which is the square root of x to the 4th. Now, if I divide 4 by 2, this right here becomes x squared. And this x stays inside of the radical, and it stays as radical x. Now look, again, 5, this 2, and this 5. If I divide 5 divided by 2, and I'll keep the color code to make sure you guys see the pattern. 5 divided by 2. How many times does 2 go into 5? Twice. What is the remainder? 1. 2, and this is a 1 inside. So therefore, there's your 1. Let's try this one. Now, this is 2 different portions, right? So we have the square root of x squared and the square root of y cubed. The square root of x squared, easy peasy, is just x. They just undo each other. Now, the square root of y cubed, we just did that above with an x, right? So how many times does 2 go into 3? Once. And how many are left? 1. So my final answer is going to be x, y. We bring these together. They're being multiplied. X, y, root y. All right, let's try these. So again, we break these up. Square root of x to the 9th, square root of y to the 10th. Here's one of the biggest mistakes people make. X to the 9th is not a number. It is a variable raised to a specific power. You are not taking the square root of 9. So this is not x cubed because the square root of 9 is 3. No. You're going to do the same thing. This is going to be, how many times does 2 go into 9? Well, 8 is the number right below it, so 4 times. So it's going to be x to the 4th. And how many are left over? 1. And this is going to be, how many times does 2 go into 10? It goes in evenly, so it's going to just be y to the 5th. So now my final answer is going to be, I'll put these together alphabetically, x to the 4th, y to the 5th, and then radical x. Okay, what happens when numbers are involved? Well, when numbers are involved, it's the same thing. You split it up and use do each thing separately. So I'm just going to do it from here. The square root of 4 is 2. That's easy. And the square root of 7, again, this is a 2. So 2 goes into 7 how many times? Well, 2 goes into 6 3 times. So we have x cubed. And then how many are left? 1. And so we have, my final answer is going to be 2x cubed radical x. Last one. 3 different parts. So we have 54. So the square root of 54. What's the biggest perfect square that goes into 54 is 9. So it's 9 times 6. And so this becomes a 3 radical 6. Okay. Next, the x becomes x to the, what number is right below, what number, even number is right below 11 is 10. X to the 10th times x. X to the 10th becomes x to the 5th. Radical x. And then, whoop, this becomes, what even number is right below 21? Y to the 20th times y. Again, because 20 plus 1 is 21. And then this becomes, again, that 2. 20 divided by 2 is 10. Y to the 10th root y. So now what I do is I take all of my outside of jail and put it together, and all of my inside of jail and put it together. So 3x to the 5th, y to the 10th, and then the square root of 6xy.